Okay? So is y equals 2 to the x an exponential function? Yeah, and essentially the big idea of what makes it exponential is that x is an exponent. Okay, so if I'm trying to come up with points on the curve, y equals 2 to the x, and I'm telling you that x is negative 2, I'm saying 2 to the negative 2 power. You guys, 2 to the negative 2 is not the same thing as 2 times negative 2. In fact, when exponents are negative, it means totally different thing than when the base is negative. Is this okay?
Yes.
What does 2 to the negative 2 power really mean?
Negative 4?
That would be 2 times negative 2, right? It's not positive 4 because 2 times... Yes?
You divide it 2 times.
Yeah, it really means 1 over 2 to the 2 power. It's that whole reciprocal thing. And guys, so what does that make 2 to the negative 2 power? 0.25. I'm going to call that 1/4, okay? But you're right. Okay. All right. What about 2 then? So if I wanted to find the y value when x is equal to negative 1, that would be 2 to the negative 1 power, which is 1/2. Yes.
I'm confused about the exponents and how you could just put it over or under 1 to give
Oh, I didn't just. I also made it positive.
Yeah.
Okay, I have like a gajillion ways to explain this. I'm going to try this one first, okay? If I say 2 to the 5th power, what does that mean?
25?
2 times 2 is 5.
It means 2 times 2 times 2 times 2 times 2. That positive 5 tells me how many times I am multiplying the 2. So, by the way, 25 would have been 5 to the 2nd power instead of 2 to the 5th. Okay, so positive exponents tell me how many times I'm multiplying that value. Negative exponents are going to do the exact opposite of that. What's the opposite of multiplying a bunch of times?
Divide it.
Dividing a bunch of times.
Nice.
Did that work?
Yeah.
Right on.
Thank you.
All right, y'all. Without telling me 0, what is 2 to the 0 power?
1.
What is anything to the 0 power? 1. Well, almost anything. There's a few weird. 0 to the 0 power is a little bit hard to define.
6.
It's what we call indeterminate. It kind of depends on the function and where it appears, yeah. Same with like infinity to the 0 power is a little bit weird. For sure. Hey, what's 2 to the 1 power? 2. And 2 to the 2 power? 4. All right, so if we then said, hey, since I'm trying to come up with a graph, negative 2 1/4 would be roughly here. And guys, if it's not exactly 1/4 of the way up, you fail for the year.
Understandable.
And all I'm doing is plotting this point, negative 2 1/4. And then I'll do negative 1 1/2. You guys with me on this? So negative 1 1/2, 0 1, 1 2, 2 4. All right. Can I connect these dots? Like, in other words, do we have points on those in-betweens? Yeah. Yeah, we can. Now, this is one of those places where, seriously, I'll get mad and you'll get irritated with me for knocking points out for you, okay? Will this graph ever cross the x-axis?
No.
What would need to happen in order for this to cross the x-axis? The whole thing would have to equal 0. Is everybody with me? So when we talk about, like, let's say I plugged in, if I plugged in negative 10, and so the top of my fraction, no matter how small I get, the top of my fraction is always going to be 1. So will it ever equal 0? No. And so what happens is we have kind of this horizontal asymptote. So the reason I'm pointing this out, y'all, is I will get irritated and take points off if you draw a graph that does cross the x-axis. Is this okay? So far, do you guys feel that you can graph exponential functions? It's literally making an xy table.
Yeah.
Cool. Okay. So, let's have a real quick definition of a logarithmic function. Now, I know I have firsthand experience that you guys have been taught about logs before. You guys with me that I have firsthand experience for just about all of you that you've learned about logs before?
Yes.
Yeah, I sat in this room while Mrs. Roth taught you guys about logs.
Yeah, I forgot about her. I forgot that all happened.
Right on. She's doing great. Thank you for asking. I'll tell her you asked how she was doing. Miss Lombardi and I went out to dinner with her a few months ago. And she's, get this, you guys. And I'm telling you, this is going to change. She says she actually prefers teaching her freshmen than teaching the juniors. Can you? No, you know what it means, right? She replaced somebody, and the juniors were expecting that person, whereas the freshmen have no idea what to expect. So they're much more, how do I say this? Moldable. Pliable. Right? So for her to set expectations with freshmen is a lot easier than setting expectations with upperclassmen. Like, if someone replaced me teaching FST, you guys wouldn't like them as much because you knew what you were getting with me. Plus, I'm the best, I know.
You should put everyone. Walter's so funny.
I can't wait to rescind his college recommendation.
Do you think he like regrets the things he says in here and cries about it later? You think Walter cries? I'm sure.
I think Walter,
Everybody cries.
I think the more I react to Walter, the more he's going to say stuff like that. I am recording this, by the way, Walter, so this should be really good. This should be really good for the folks who aren't here, yeah.
Ms. Meister, you could send that recording to Walter's colleges.
I could, that would be pretty funny.
As part of the recommendation.
As part of the faculty respect component, yeah. All right, y'all. Logarithmic functions. Okay. I don't want us to flip out about logarithms, but, you know, people hate them. You'll get over it.
I'm so good at it.
Good.
Doesn't mean I remember it.
All right, you guys. If I tell you that 2 to the 3rd power equals 8, is anybody shocked by that?
I'm amazed.
Okay. All a logarithm does is separates an exponent from its base. Okay? So this would become log base 2, but the whole point of the log is to flip-flop these two values. So log base 2 of 8 equals 3. The value of a logarithm is an exponent. Say that again. The value, what the log is equal to is the exponent that gets you to the 8. What exponent do I put on 2 so that I get to that 8? 3. So likewise, guys, if I gave you log base 10 of 1,000, 10 to what power gives me 1,000?
100?
10. Okay, let's do this together. 10 times 10 is? 100 times 10 is? 1,000. So 10 to what power gives me 1,000?
3.
She really has it in her fingers.
I can't. I couldn't see the finger.
You guys, I'm out of coffee. I don't know what we're going to do, how we're going to get through this. Is everybody with me?
Yeah.
So what is log base 10 of 1,000?
3.
What is log base 10 of 10,000?
4.
What is log base 5 of 25? 5 to, so again, you're asking yourself, 5 to what power gets me to 25? 2. What is log, you guys ready for the trick question, right?
Probably not.
What is log base 5 of 1 over 25?
Negative 2.
See, you guys were ready for the trick question I was going to throw at you.
What is the trick question?
What is log base 5 and 1 over 25?
I was just unsure because we didn't know what 1,000 was.
Yeah.
See how for
All right. So,
I'm scared right now.
you guys, are you with me that if I'm trying to graph the function y equals log base 2 of x, that this is an annoying question for me to ask you?
Yeah.
I agree. So why don't we rewrite it? Isn't this basically saying that 2 to the y power will equal x? The value of the log is equal to whatever that exponent is. So y is just an exponent. Is everybody okay?
Yeah.
Now, it is way easier to fill in an exponent than to find an exponent. Are we comfortable with that? So why don't we make all those y's -2, -1, 0, 1, and 2 so it's easier to plug into? We still feeling okay? So if I want to find x when y equals -2, I'm going to do 2 to the -2 power. What is 2 to the -2 power? 1 over 4. What is 2 to the -1 power? What is 2 to the 0 power? What is 2 to the first power? What is 2 squared? And can I graph those exact points?
Yes.
And let's see. I would do 1/4 -2 would now be right here. And then 1/2 -1 would be here. And then 1, 0 would be here. And 2, 1, 4, 2. Will this ever cross the x or the y-axis?
No.
For the exact same reasons, yes? And in fact, you guys, there's a log button on your calculator, yes?
I've been looking for it and I'm not.
So it's over on the left.
Next to the
There
seven.
it is. It says a lot.
Guys, go ahead and do the log of -7. How'd that go for you?
No real answer.
No real answer. Why? Because you can't take the log of a negative number for the same reason as it can't cross the x-axis. Something to a power can't be negative. At least not for a function-y thingy. Okay, so you aren't going to cross that x-axis, right? Or the x-axis. You're not for the logarithmic functions. I'm not going to ask you to cross the y-axis.
Where's
Yeah.
the button? I've lost
On the left?
it.
How does he think of this? How did he think of this?
I don't know, but he's got a pun for every equation. Equation? I didn't do that on purpose, but that one was kind of funny. He's got a pun for every equation instead of a pun for every occasion.
Miss Meister, that was a little funny.
It was. That's actually one of the more funny things that's going to happen to me today, you guys. Oh, are you working after school today? Yes. I can't wait to bug Mackenzie at work today, guys.
Where do you work?
Wait,
Tea, sorry.
Mackenzie, do you serve peanut butter mocha extra large?
I know.
gets the
I need
tea
to
so
start
that
getting an
I
ice
can-
cube in the tea because it's too hot.
She gets the tea so that her car can smell good.
Except for
You rode your bike.
I rode my bike. So
So
I'm
maybe-
going to get a small today too because I rode my bike.
Or you could get a mug.
Makes the inside of the bike smells good.
All right. Hey guys, will you fill out this XY table for me, please?
I'll start on
I never took attendance.
Miss Meister,
Yes?
would it be 1/6?
It would not.
It would not.
It would be 1/9 because you would be 3 times 3. 3 times itself twice.
Thank you.
Oh wait, isn't it 3 versus 1?
whole internet situation. Are you guys having any Wi-Fi issues?
I don't use Wi-Fi. I don't think I've actually pulled out my computer once today. That's a hard worker right there.
Yeah.
Well, none of my closets
So
are
it's just
required.
like one over and then three to the second.
This doesn't look right.
Have you tried using the hotspot on your phone?
I don't have a hotspot on my phone.
Oh,
What about your iPad?
Oh, the zero is a 1, that's why. Cause
Anything that is zero.
yeah, that's what I was blanking because I switched it with the to the
push it, uncall Tom.
I just heard noises.
You were just checking in on it.
Yeah, Savannah and I care about it.
I would call this
You were making noises back there.
exponential. I would call them both exponential in nature, yeah.
Savannah, we have the timer.
So that as that base changes, which is really what happened there, right? The further the base is from 1, the more sharp that turn is going to be. But like, so if I did 1.5, it would be like more round versus it would like this.
I really drink very quickly.
Yeah. Okay, so guys, if I know y equals 3 to the x looks like this one, how could I very, very quickly get my xy table for log base 3 of x? Flip all the x and y coordinates. So I'm going to have 1/9, -2, 1/3, -1, 1, 0, 3, 1, 9, 2.
This is gonna get confusing pretty bad.
I actually didn't what class would we have done this in?
Pouch 2 and maybe pre-calc.
I think we did it in pre-calc and I remember not minding this. Like when you couldn't put it on the accents.
Well, we're kind of doing this in pre-calc.
Are we done?
I don't know what we're doing.
How do you know we're done, Mom?
I didn't say that. Now, no, someone over there said it. Here's the deal. You guys, would you rather have an easy Thursday or an easy Friday?
Easy Thursday.
Easy.
Thursday.
Thursday.
put away.
Friday.
No,
Thursday.
can you please keep going?
I had a very long day yesterday.
I just don't
Easy Friday.
I'm thinking
I agree with that.
I was planning on doing the first half of tomorrow's stuff today,
But also.
but not all of it. But that way tomorrow doesn't go bell to bell because tomorrow's is a longer lesson.
Please, let's go.
Okay, so
Come on, you were
rats.
ready to go.
Or maybe we could just, use this time for you to get your Wi-Fi fixed.
I mean, I don't need Wi-Fi. I've taken attendance,
Oh.
which is all I really wanted the Wi-Fi for. All right, you guys. So today we're going to focus on using logarithms to help us, okay? And there's one really, really lovely property of logarithms, okay? It goes like this. If I tell you log base 3 of 5 to the 7th power, okay? You know how this is, we just said, what is the value of a logarithm equal?
The exponent.
An exponent. So this is saying an exponent raised to another exponent's power. Okay? Which means I could rewrite this. Like, if I gave you x to the 3rd to the 7th power, what would you do with those exponents?
Add them.
We'd multiply them. So I can multiply this this 7 exponent times the whole logarithm. So I can turn this into 7 times log base 3 of 5, which is a really, really awesome property. Okay? So as I look at the equation 2 to the x minus 5 power equals 8, what's frustrating is, like, if I had something like, if I just had the x minus 5, I could do the opposite. I could just add 5 to both sides. Do you guys see what I'm saying here? But that's not what I have here. All right. Now, the quickest and fastest way to solve an equation that has a variable that is an exponent is, if you can, rewrite so that both sides are the same base to the same power. Are you guys with me? 2 to the third is equal to 8. So I can take that 8 away and put 2 to the third in its place. So now, what value for x makes this a true statement? I know that x, whatever x minus 5 is equal to, what is it? What does x minus 5 have to equal? 3. Right? As long as these two bases match each other, we can do this. Okay? That's the easiest way to do it. If I give you x minus 5 equals 3, we get x equals 8. Okay. Now, slight flaw with using that strategy. You guys, I'm like good at numbers, right? I don't know 6 to any power. In fact, I don't know anything to any power that equals 99. We okay? So, what we're going to do is take, and I can choose any version log that I want, log base 2, log base 3. I'm going to choose log base 10. And log base 10 is when we write log with nothing there. Why do you think, and we call that the common logarithm, why do you think common log, the most commonly used logarithm, is log base 10?
Because we use the base 10 number system.
Because our number system is base 10. And why is our number system base 10?
Because somebody said so.
Nope. I kid you not.
Oh.
You can't see me because I could have worn my chacos because it was warm enough today, but you can't see me wiggling my toes. But I am wiggling them too. Okay, so we have base 10 number system because we have 10 fingers, 10 toes. So it's literally people would count to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 20, 30. Think about, as you learned different ways of counting, you learned 1, 2, 3, 4, 5, right? Then you did 2, 4, 6, 8, 10, 12, right? Then you did 5, 10, 15, 20, right? Then 10, 20, 30, 40. Right? We think in base 10. And by the way, counting by 2s and then counting by 5s eventually led to counting by 10s. Do we see the 2s and 5s and 10s? Is everybody with me? Okay. All right. So remember what we just said. If I have a log here, I'm allowed to bring any exponent down in front. So really what this is saying is x plus 4 times the log of 6 equals the log of 99. So now if I wanted to figure out what x is, what would I do?
Do we have to use PEMDAS for this?
Nope. I mean, you can. Well, technically, when we solve equations, we do SADMAP.
What is SADMAP?
PEMDAS backwards. You undo the order of operations.
Can we get rid of the logs? You do log 99 divided by log 6.
You can divide both sides by anything you want. Now, you guys, this is important. This is not saying log times 99 divided by log times 6. Like, I can't just do this. Okay? You actually have to type in your calculator log 99 divided by log 6. You have that, and your calculator, I think, will automatically put an open parenthesis on that 99. I'm pretty sure it automatically does. You need to put the other parenthesis, which is above the 7. You need to close that parenthesis before you hit the divide by.
It's above the 9.
It's above. It was close enough. I got you so your eyeballs would be in the right place.
Well, I was just helping you help other people.
Would that be
2.5
or
6.
5, 6?
2.56, is that what you guys are all getting?
Yes.
Cool.
It's kind of scary.
So what does that make x?
X would be negative 1.44. Nice. Uh-oh. Is it our turn now?
It's not your turn yet. What would you do first?
Divide both sides by 4.
Yeah, this 4 out in front is problematic. So we're gonna, as long as whatever we do to both sides, we're good. So I'll get 2 to the x plus 5 equals 22. Now what would you do?
Log.
Take the log both sides. I'll get x plus 5 times the log of 2 equals the log of 22.
It's my turn.
Oh, that's, yeah, I get that.
I was just trying to be funny. I was just trying to be funny to you guys.
No, I mean,
Wait, this is my turn.
I didn't get
I got negative 0.54.
What did you get?
I got negative 0.4.
So what did I do wrong? You should
Oh, I know what you did wrong.
have asked Sabina.
Why?
So we gotta be careful.
What's your favorite type of boy?
Oh, I forgot the. No, I know what I did. I forgot the parenthesis.
Yeah. Yeah. Hey guys, what's log 22 divided by log 2?
4.46.
So that makes x negative 0.54.
No? Yes, it would.
How did you do that in your head?
Because I'm brilliant.
I say that's weird.
That's pretty crazy.
Safina. All right.
You can look at my paper.
I have way better things to commit to my memory than how to do some arithmetic. We go to a tennis court, right? And I try to serve, and you'll laugh at me, right?
No.
No, you would. It's really
She
bad.
does
Somebody
sometimes
laughs at me.
laugh.
Okay, what I'm saying is something you have practiced over and over and over again. To you, might feel a little bit more easy than me, yeah? Do you know how many times I do simple addition and subtraction problems in a day? Like, a day. 73,552 on average. I made that up.